Let's talk about a piece of technology so foundational to our modern world that you almost certainly used it today, but you've probably never even seen it. It's a programming language that's been declared dead for decades, yet it just refuses to go away. Okay, to really get a sense of what we're dealing with, I want you to just picture the world before we'd even won the space race, before color TV was a common thing. That's the era we're in, a time of massive computers that literally took up entire rooms. And that's where our story begins. And look, this isn't some beloved, retro cool piece of tech. It has a reputation. A really, really bad one among a lot of people in the field. So bad, in fact, that one of the most respected figures in all of computer science said teaching it was actively harmful to the human mind. So, we've got this ancient, widely criticized piece of tech. The story should end there, right? It should be a relic in a museum. But it doesn't. And that's the puzzle we're going to unpack today. Because this relic is hiding in plain sight, powering the very systems that handle your money, your travel, and even your government services. So where did this all begin? I mean, to understand why this seemingly ancient language has such a powerful grip on our world, we have to go right back to the very beginning. The year is 1959. To set the scene for you, Eisenhower is president, Alaska and Hawaii just became states, and NASA just launched 2 monkeys into space and brought them back safely for the first time. And in the world of computing, a brand new language is born. It was called COBOL, and its name pretty much gives the whole game away. It wasn't designed for scientists or academics. It stood for Common Business-Oriented Language. Its purpose was laser-focused on one thing: solving business problems. And it was built on 2 ideas that for the time were absolutely revolutionary. First, it was hardware independent. This was huge. It meant a program you wrote for an IBM machine could, in theory, run on a machine from a totally different company. And second, it was designed to read like plain English, so that managers, not just the engineers, could actually understand what the code was supposed to be doing. And you can really see this commitment to readability in the code itself. A completely valid command is just add years to age. You don't need a computer science degree to figure out what that does. The simplicity, well, that was its greatest strength. It made programming accessible to the business world. But that very simplicity, that English-like style, well, it would eventually lead to a massive backlash from the academic and computer science community. The most famous criticism came from Edsger Dijkstra, a giant in the field who won the Turing Award, which is basically the Nobel Prize for computing. In 1975, he wrote this absolutely scathing takedown. He wasn't just saying COBOL was a bad language, he was saying it was intellectually damaging. And for a lot of people, that quote was the final word. COBOL was a dead end, a bad idea. But was the story really that simple? Well, another computer scientist, Howard E. Tompkins, he pushed back. He argued that the problem wasn't COBOL itself. The problem was that a lot of programmers were just writing messy, convoluted code. He believed that if you used it properly, with good structure, COBOL was perfectly fine. So this framed the whole debate. Was the tool itself bad, or were people just using it badly? For decades, it really seemed like the critics were winning. You'd hear people talk about COBOL as a legacy or dead language. But quietly, behind the scenes, something else was happening. The language wasn't dying, it was evolving. So after all that history and all that criticism, we have to ask the big question. Is COBOL actually dead? Well, let's just look at the evidence. First off, for a language to be alive, you need tools to translate its code into a program a computer can run. They're called compilers. And as you can see, tech giants like IBM and Fujitsu are actively developing and selling them. There's even a major open source version. This is not what a dead language looks like. And you don't need some ancient computer to write it either. You can write and manage COBOL code in the same modern editors that developers use for Python or JavaScript, things like Visual Studio Code or Eclipse. It fits right into a modern developer's toolkit. And this is where it gets really interesting. Developing in COBOL isn't stuck in the past. Teams use modern tools like Git to track changes and Jenkins to automatically test and deploy their code. The implication here is huge. You can manage a massive, decades-old COBOL system with the same efficiency and safety as a brand new web application. So we've established that COBOL is far from dead. It's a living, breathing language with a modern ecosystem. But why should you care? Why does any of this matter? Because this isn't just a fun piece of trivia for programmers. The survival of COBOL is directly responsible for much of the world's financial infrastructure. It is the ghost in the machine, silently and reliably doing its job every single day. And that job happens on mainframes. These are powerful, ultra-reliable computers that are the heart of the world's largest banks, insurance companies, and government agencies. When you withdraw cash from an ATM or you check your account balance, a COBOL program on a mainframe is almost certainly processing that transaction. These systems have billions of lines of code, and the risk of replacing them is so immense that it's just safer to keep them running.
For half a century, experts have been writing COBOL's obituary, and for half a century, it has just kept working. It proves that new and flashy isn't always better, and it makes you wonder, what if the most critical, most important technology isn't the app on your phone, but the invisible, reliable code that's been running silently in the background all along?